Okay, we might get started now because you don't want to. I'm the last guy who's going to present before lunch, and the last thing I want to do is get it between you guys and your food. So my presentation probably won't be quite as long as everyone else's. So welcome to the third and final presentation for today's Xamarin Dev Days. So this session is about connected and disconnected apps with Azure mobile apps. First and foremost, my name's Dan. I'm an enterprise integration consultant for Mexia. There's a few things about me up there, but probably the most interesting thing that you'd want to know is that I am not a mobile app developer. And in fact, I have never written a single line of Xamarin in my entire life. So you're probably wondering, why is this guy up here and presenting for you? And that's a really good question. It feels a little bit like this. So if you're a Gary Larson fan, you'll remember that guy. I think it's called The Elephant's Nightmare. But the reason I'm actually here is because this particular presentation isn't really about developing the apps and the user interfaces and everything that you're used to seeing on the phone. What it is about is taking those beautiful apps that you can create using Xamarin and then being able to connect it to your backend data. Because basically, unless your apps can access the data that it needs to in order to run, it's not going to be terribly useful. And specifically, we're going to talk about how easy it is to do that using Azure mobile apps. So just a few interesting statistics about apps. It shows how much we love them. There's almost 200 million downloads a day for apps. And people on average spend about 200 minutes on their phone. And of that time on their phone or their devices, they're spending more than half of that time in their applications. It's almost like nobody uses a phone for what it was originally intended anymore, to actually talk. So that's a lot of time invested in those applications. And Google did a survey of all their Android devices, and they came up with this statistic that the average app user has 36 apps installed on their phone. So how many would fit in that category? I actually think I have quite a few more on mine. But what's really interesting about that is that only a quarter of those apps are actually used daily. So that might make sense because you think, well, you've got some apps that you might use a little less frequently, like shopping or whatever, or maps or things like that. But then going further, another quarter of the apps are never used, which is actually quite an interesting percentage. So you actually install the app on the phone, but never actually run it, or maybe only run it once and never run it again. So what are the reasons for that? Well, probably you'd have to attribute a fair amount of that to having some bad app experiences. So for example, if you run the app and it's really, really slow and laggy and just doesn't work, then people are going to get very impatient. We kind of expect things to run at a certain speed these days. If the app crashes, that's pretty bad news. So another statistic is that if an app crashes the first or second time somebody uses it, then the chances are less than 15% that they will ever open that app again on that device. So you want to make sure your app is going to work first time, because otherwise you're pretty good chance that it will never be used. Another thing is not a very intuitive user experience on it. So I've seen this quite a bit, and even Microsoft gets it wrong, right? Like when Windows 8 came out the first time, and everybody's wondering, where's the start button? All the design sort of paradigm going towards very, very simplistic and clean user interface. Sometimes, I don't know about you, but sometimes with certain apps, I have a hard time figuring out where things are, where the control is, and what magic finger swipe do you have to do to get something to appear that you use all the time. So that's also a contributing factor. And of course, if you're putting your app in the store and your advertising has certain features, you better make sure the features are actually there. But I think another issue, and one that we'll probably talk more about today, is when the data isn't available when you need it. And I'm talking specifically when you have to go offline, right? If it has a dependency on being connected. Obviously, if you're going to use Facebook, you would expect that Facebook is pretty useless if you're not online. But thinking about something like email, for example, on your Gmail app, it only keeps about a couple of days worth of emails on it. So if I have a manager or a friend who sent me an email last week, and I'd like to be able to see it on the phone, and I don't necessarily want to have to be connected to the internet to be able to find it. So the question is, we get used to being in an environment where we're almost always connected to the internet. But at those times when you go out to an area where you're not, that's where you start to suffer, because you have the same expectations that your application will be useful to you, but if it's not connected, will it be useful? So just having a look at this map of the United States, this is a chart showing the coverage by the various phone companies there. And you can see that, as you might expect, first world country, they have really pretty good coverage. Obviously, it's much more heavier coverage in the more populated areas of the east of the United States. But if you get out to states like Iowa or Wyoming or Idaho, then you're going to start hitting a lot of patches that actually don't have coverage. So then if you go to another country like Africa, which is the biggest continent, but obviously has very, very poor network coverage compared to other countries like India or the United States, it's even more interesting. This chart shows the coverage for all of the bandwidths from 2G on up. But if you remove the lower ones and just show the 4G, it's even worse. So even the coverage that they do have isn't necessarily good bandwidth and very useful for the kind of applications we develop today. So what this is about is you want to try to develop your apps to create a sense of a connected experience even when you're not connected, right? If that's possible. So you don't want your access to your data always to be dependent on being online if you can manage your app like that. Now that requires certain things. It requires an offline synchronization type of mechanism, which if you have to write one on your own isn't very, very easy. But we'll talk a little bit more about that later. So what's unique about Xamarin is the fact that it's basically C# end-to-end for you. So you have it not only in the front end and also in the shared service, but your back-end server as well can run C#. So that gives you a sense of a seamless capability and sort of high performance from being able to have that programming language available to you the whole way through. So what about that backend? So there's plenty of options for you to use for the backend. The ones on the left side here, like Azure, Amazon, and Oracle, are primarily cloud-connected experiences, whereas the ones on the right side are more disconnected, offline types of experiences. Xamarin works with all of these. But when it comes to choosing what your backend platform is, obviously, for you guys anyway, the developer experience and how good that experience is going to be one of the critical factors in it. And Azure mobile apps gives you a fantastic experience for developers. And I hope to be able to show some of that to you today. So why Azure? It's extremely powerful. I mean, you can do pretty much anything that your backend would ever have to do using Azure. For whether that's data storage, authentication, push notifications, custom APIs, blob storage, all of that is capable. I like this this slide. If you guys have seen this before, this is a bit of a clever rendition of the more official Microsoft slide that has all the services on it. But you can see that with Azure, you get pretty much everything. I mean, you've got from all kinds of different storage to then intelligence, business intelligence from data processing like machine learning and stream analytics. You've got processing from your VMs and cloud services. You've got all kinds of connectivity through the network options that are available and integration features. So it's just basically an endless supply of services that you can use and leverage in your applications. It's also very, very flexible. Azure mobile apps, the back end can be either in Node.js or C# or SQL Azure or pretty much whatever you really want. If you want something lightweight, you can build that very easily. And if you need something a little bit more robust from like an enterprise quality type of app, then certainly you've got all that power in Azure available to you. And of course, it's C# everywhere, as I've mentioned already. I mean, it's from the front end all the way to the back end. And what's great about C#? Well, it's a familiar language. We all know about it. It's got all kinds of built-in abstracts for you that make things easy, like consuming a RESTful API. It's got async await built into it, other C# idioms like properties and Fluent API. And in the back end, you can be as advanced as you want. For example, if you want to use ASP.NET, that can work as well. So C#, it's a first-class citizen, which is not to be underestimated. So with Azure mobile apps, you start with an SDK, which enables you to develop the code that connects your Xamarin to your device, runs in your client, and it talks to the backend services through a REST API. And those backend services can include all kinds of things available in Azure, including your data connections, so ability to connect to the SQL or or Mongo or any of your custom API apps. It also bundles with it authentication, so you can either roll your own if you want to, or you can use Azure Active Directory, or use any one of these other federated providers that you have, like Facebook or Twitter or Microsoft. It also includes a feature called push notifications, which is a topic on its own, but it's quite an interesting, powerful facility for you to be able to broadcast messages out to a variety of devices without having to worry about what the configuration for those devices is. And another thing that's built in, which is kind of interesting, and this is what we were talking about before, is this offline sync capability. So obviously, if you wanted to create that ability, you could roll your own, but you actually get this bundled with mobile services, and it's quite easy to enable it. So it even can handle merge conflict and stuff like that. So, and with your backend services, basically can be hosted anywhere and deployed from anywhere. For example, if you want them in GitHub or TFS, Visual Studio, in a web app, it's fine. That's where you can have it hosted. So there's a lot of flexibility there. So when you're creating an Azure mobile service, obviously first thing is that there are some SDKs and some NuGets that you need to get into your Visual Studio, quite readily available. And then when you start your code, it's very simple. You create a mobile service client, and all you need to do is pass in the endpoint for your service, which you've created in Azure. So the mobile service client is basically a host for accessing all those features in Azure, like, for example, push notifications and offline sync. And as I mentioned, the endpoint is usually it's the Azure website or wherever it is that you're actually hosting your backend service. Then the next step would be to create a store. And that store is shared between your backend and your device, right? So it basically is a data structure that's defined by you. So in this example, store is actually a custom data structure. So you might say maybe this app belongs to somebody who owns a bunch of stores and he wants to manage them through his phone. So you create the store, and then with that you can add a sync handler for it. Out of the box, you get one that already has its own conflicts in it, but you can also roll your own if you want to create your own conflict handler as well. So basically, you give it a table, and then you get back a table with your sync. So if you want to actually pull your stores, it simply uses a link-like query, which just says pull async. All stores represents a keyword that means you're going to get all the data that's stored, but you can also put your own filters like you would for any link query and be able to pull back the data. And if you want to add a store, basically you're going to insert your new store that you created on your device, and then you're going to pull to get them all back, and then synchronize so that the store in the back end and the store on your phone is all synchronized. So let's actually jump into a demo, and I'll show you how this works. So what we have here is I'm logged in to the Azure portal, and I'm just going to take you through the process of actually setting up a mobile app. Although I'm not going to do it because we don't want to sit here and burn minutes while it creates it. I've already created one already. But basically, if you do a search and you just do mobile app, you'll get this mobile apps quick start. So the quick start, the difference between that and the mobile apps is that the mobile apps will just give you the boilerplate stuff, whereas the quick start will actually set up a SQLite table for you and on all the functionality just to get you up and running with an example. And you can replace all of that if you want. So to create one of these, it's very simple. All you need to supply is a unique name. So just doesn't matter what I name this, Dan's test. Choose your subscription. You can either use an existing or create a new resource group. I'll probably generally create a new one because it's just easier than to delete it if I think I'm going to be throwing it away later. And you can choose your app service plan. This one is fine because I know it's free. And then you'd just click create, and it takes about 4 or 5 minutes, I think, for it to run and then spin up. So it's really not that long at all, but I just don't want to burn the time in the presentation. So we'll abandon that for right now, and I'll show you the one that I actually have already. Gosh, there's so many blades. Here we go. So Dev Days Briz. So just open this one. And this is the blade that will launch as soon as it's created for you. So we got a few things in here to see. So if you want to see the particulars about the service, you can go to this page, and that will give you. It should be very, very familiar to you if you've done any web apps, right? It looks almost exactly the same. So you've got your URL where everything is running, all the properties that you can control. You've also got access to documentation that will launch a web browser window for you. And you've got this concept of easy tables, which I think you're going to be working with in the labs later today. So with the Quick Start mobile app, it will create a SQLite table for you automatically called To-Do List. There's a warning here that tells you that it's SQLite and it's not recommended for using in production. So once you've done your initial testing, you want to replace that with a proper SQL Azure or another kind of data store, that's fine. But for this demo, we'll just go with the SQLite. And you can see that you've got a table there. Right now, it has nothing in it. You've also got authentication. So by default, there's no authentication turned on, but you can choose from a variety of different providers for that. Okay. In addition to authentication, you've also got the ability to actually look at the code that's behind. So this opens up another web page, and you can actually see all the modules that actually make up this service in the back end, and you can even edit the code if you want to. So you've got all of your Node modules here, your app.js, which by the way, there is something that we will change in here, and you probably should. I'll show you why in a second. If we go back to the settings page, and we want to actually see the endpoint here, if we click that, you'll get sort of this boilerplate page that tells you that your service is up and running. It's the first time it's launched, so that's why it's a little slow. So if I go try it out, I'm going to get this nice little message that tells me that you need to enable Swagger. So how many of you are familiar with Swagger? Yeah, a lot of you are, right? Okay, or a fair amount of you. Okay, so Swagger is actually really cool, but it's not enabled by default. So when you go into that code view, if you go into the app.js file, and this is really what that message on the browser was telling you to do, there's this line here that says, commented out, that says Swagger true. So you just need to uncomment that. Now with these code files, you don't even have to save them. Your changes are just automatically saved for you as you make them. You can see up here it says saved. So if I go back into this website and refresh that page, you should get the Swagger for it, which is really quite nice because it documents what your service is capable of doing. You can list all of the operations that are available on it, and then you can even test those operations for within this user interface. So it's actually quite cool. So you can see that that this service already exposes methods for get, post, delete. Actually, a couple of different gets and posts too. One where you can actually pass in a specific ID. So remember I said that your SDK that you work with for the client code talks by a REST API to your service. So this is it. This is the REST API. So that's basically what you have in the portal. And then you've got this tile that says Connect Client Apps. So if you've already created a client app, then you can certainly connect an existing one if you want. But here, what you do is you can choose what kind of app that you want to connect to. For this case, I think we'll just go with Xamarin Forms because that's what we've been talking about today. And if you go in there, it will tell you a few things. So it says you already have a data connection, and that's because this quick setup gave you a SQLite database to use, and it's created that table for you. Here you can either connect an existing app if you've already created your front end, or you can download the code, and that will basically download a Visual Studio solution for you that has all the code that you need to get started with your service. So I don't need to do that because I've already got it open for the service that I've created. So that Visual Studio solution looks like this, and you'll see that it comes with projects for Android, for iOS, for Windows Phone, and just a Windows application in it. And then, of course, you have the service itself, which represents the backend code that's running. We just have a look through what we can see in there. Now, to get this to work and compile, there'll be a few NuGet packages it gets, but you also need some extensions. So I'm just going to show you which ones those are. Oh, SDKs. So you will want the the SQLite ones if you're going to use this example, and that's simply because it's using a SQLite database. So, and that's also what's going to enable offline sync to happen. So you want to install those extensions. The nice thing about this quick start thing is it generates the model for you. So we have here a model for a to-do item, and it's just basically a class with a couple of properties in it. So you have an ID, you have a description of the item, a flag that indicates whether or not it's completed, and of course a version on it as well. You get a bit of XAML that comes with it. So if we look at that, it gives you a landing screen. There's an activity indicator. There's a button that says, there would be an entry form for you to actually create a new item. It's just a text box for you. And then a button that says add, which they just do with a plus sign on it. And then you've got a list view underneath it. So it's a pretty simple app, obviously, right? You have also the app C# file, which basically does the initialization, and it creates a new to-do list item, which is your XAML item, and that's this one here. If we look at the class underneath, so we can see code that gets executed. You got some initialization that happens. This isn't enabled by default, by the way, but if you go into that manager code, out of the box, this define will be commented out. So it gives you the instructions here of what you have to do. You need to uncomment that if you want to enable offline sync. You also need to get this package here and install that. Now, I had some issues with that when I was doing it, so something I'll probably just mention. If you do a little bit of search, you'll come up with a page. Okay, let's just do that, see if it goes away. The tab that I want to access is hidden behind that. Okay, so you might get an error when you try to run your app. It'll compile and then it'll tell you that it can't initialize. It'll be a type initializer problem, but if you dig down far enough into the exceptions, you'll get this unable to load SQLite 3 DLL. So the solution for it is that you need to go in and basically explicitly add the extension to your application. And I'll show you which one that is. That's in here. So it's in the service application, and if you go, it's not in the service application, it's in the target client that you're wanting to run, which in my case was the Windows app. The one is this SQLite for Windows runtime, and also the Visual C++ runtime package for Windows. So just in case you run into that issue, that's how you can solve that one. So that's basically a lap around the code that you get. So what I've done is I would love to be able to show you the Android emulator and stuff, but because I'm running my code inside a Hyper-V VM, and the emulator for Android actually creates its own Hyper-V VM, it's not supported running inside another VM. So the only thing I can show you right now is the Windows app running this. So I'll set that as a startup project. I'll just build the solution. Oh, sorry, there is one other thing I need to show you. If you download the code from the website where you've created the Azure mobile service, or mobile app rather, then this will already be set for you to the proper URL. But if you've downloaded this or you want to connect to another mobile app in the back end, then you just simply need to go into this constants file and update that endpoint. So this should be all set to go. I'll just build the application and we'll run it. Okay, build succeeded, and then we'll go ahead and launch it. Okay, so at the moment there's nothing in my to-do list, and we could verify that by going to that Swagger page and executing the get. If I hit try it out and it runs, you'll see that the response comes back with an empty message body. So let's try adding an item. Let's say try mobile app. Okay, add that. We'll click the plus sign, and that entry has been created locally on my phone. So if I execute this, I don't expect to see that appearing here, and it doesn't. So it hasn't made it back to the backend service because the default behavior for this is to only store it locally. For this app, the way it's been written, I need to actually manually sync the items. So if I click that, This will do my offline sync. And then if I go and execute this again, there you can see now my to-do list item has been added. And if I want to, I can try posting an item from here in the server, in the backend, and seeing if I can get to appear in the phone. So there's a post method here, and it gives you an example value to add in. Now I know from experience that it doesn't like you to manually set these properties, so I'm just going to delete those. Set complete is false because it isn't completed. And we'll just say another item. So I'm going to go ahead and post that. So that was successful, I think. And we can prove that by just querying here. We should, yep, we got 2 items now in the server side of our SQLite database. So if I now sync items in this phone, hopefully that will appear. Obviously, I didn't make an acceptable sacrifice to the demo god, so that's. Well, this sync items button should, as I understand the way the code's supposed to work, it should be actually querying the backend store and getting it. So, add an extra item? I could add an extra item for sure. Yeah. Okay. So we'll go ahead and add that. Again, that won't appear in the backend store until I manually sync it. So if we do that, we only see the 2 items original. But if I sync items, we should. Yeah, here's another. So it seems to be, the synchronization seems to be working going to the service, but not so much from the service back, which is an interesting issue. I don't know if it has to do with, it should. I'm pretty sure the demo should be working that way. But we can always look at the code and right, but it seems that when we queried it, if you look at it here, it seems like all the fields are set, right? So we can see them. There's nothing missed. And the version is correct on all of them, too, so both the ones I created in the back end and the front end. So, yeah, not entirely sure why that's working. So if we look at that to-do item manager and what the code is doing, or what it's supposed to be doing, so first we have get to-do items. And we have here a flag that says whether to sync items by default or not. So by default, when you do a get items, it will get only from your local store first, unless you manually do the sync. But basically, this query here is operating against the local store. Then if we want to add an item, it calls the save task async. So the first thing it does is it inserts the item, and then it does an actually, that's interesting. It doesn't. Well, let's just see what it does, actually. Go to definition. That's right. That's what it does. Okay. So it's just determining. So that saves the task, but then nothing actually goes to the back end until you actually perform the sync. So this is where it should go when I click that button. And the first thing it does is it does a push. So if there's anything that you've saved on your device and it hasn't been committed yet to the back end, it will do that first. Then it will execute a pull and simply get back all of the items, which actually is all the items that aren't complete. And then there's just some basic error handling that's built in case there's any merge conflicts. So the merge conflict happens automatically in this service, so it may not be the most robust one. It'd be nice if it actually worked 2 ways. But you can obviously write your own code to do that. This is just giving you the stuff out of the box that you can use to get up and running. I think that was all I needed to show you in the code. So, as we talked about before with Xamarin, it isn't just the front end that is in C#, it's C# all the way to the back end as well. There's other features as well that we can control, which we don't dive into today because we don't have time, but obviously authentication. Mobile app gives you the opportunity to create authentication without having to roll your own, because that would be fairly complicated to do. And as you saw on that page, you had the option of using Azure Active Directory, Facebook, Twitter, Google, pretty much anything that's OAuth 2. Push notifications, again, a really cool feature. So if you need to broadcast to a bunch of devices, for example, suppose you want to send a message out to all your employees in your company, all their devices can be registered through a notification hub. You send out the message once, and the hub takes care of sending those messages out to each of those devices, and it doesn't matter what platform those devices are running under. It handles all of that negotiation for you. And then here we were doing an example of some structured data, like a to-do list, but it can handle unstructured data just as well, too. So for example, if you want images, you want to synchronize photos among devices or a server, then that's very easy to do as well. You can use blob storage, for example. Now, you saw it wasn't a whole lot of code that we had to use to get this up and running, but something that can simplify that even more is app service helpers. And I think you're going to be working with that in the labs today. This is basically available off of GitHub, and what it is it's built on top of the Azure Mobile SDK. So it still uses all of that technology. It just makes things simpler by sort of lowering the barriers, by making things easier. You can basically get up and running with a mobile service in 4 lines of code. It's all open source, and here are the 4 lines of code that basically can get you the entire backend set up and synchronizing tables. So you'll find out a bit more about that this afternoon, I think. And it's available on GitHub. That's the link for it. If that isn't already in your lab this afternoon, which I'd be surprised if it isn't, let me know. I can get you that link. And just before I finish, I'll just give a shout out to the Brisbane Azure user group, which I'm the organizer for. If you're interested in finding out more about Azure, we meet once a month, always on the second Wednesday of the month. It's a Wednesday evening. There's free pizza and beer. And yeah, we have a very, very active group. It's on Meetup. We have about 300 people who actually belong to the Meetup, but we get anywhere from 35 to 60 people showing up each month. And those meetings are right here. So if you want to join and find the Meetup, if you can't find the Meetup, tap me on the shoulder. I'll point you in the right direction for it. So unless there's any questions, other than where's lunch, then thank you very much, everyone.